MISO is an independent organization that manages a large portion of the bulk electric system through an organized market approach. This approach provides the real price of wholesale electricity, which has a huge intraday and geographical variance. Exposing these prices, coupled with technology and tariff advances over the past several years, provides even more opportunities at the retail level. These additional opportunities lie in improved coordination between the wholesale and retail markets. Improvements in communicating accurate retail price signals to end-use consumers, coupled with providing them with access, directly or indirectly, to the wholesale markets, would allow their consumption decisions to actually provide benefit to themselves and general market outcomes. To the extent these opportunities are wisely pursued, the bulk electric system is made less expensive and more reliable for all. This may soon be possible, but there's still a lot to be done. This presentation was developed to show how the wholesale market works and why it is important to retail pricing decisions and ultimately the end customer. While this video is based on events within the MISO footprint, the observations made in the presentation would apply to virtually all RTOs. MISO is an independent, voluntary nonprofit entity that encompasses all or part of 11 states in the Midwest. MISO runs one of the world's largest real-time wholesale electric energy markets, directing and controlling over 131,000 megawatts of generating resources and approximately 50,000 miles of transmission lines. Consumer loads in the MISO region have been as high as 104,000 megawatts during peak summer days, and MISO settles more than $23 billion in gross market charges annually. This is a price map. MISO uses price maps to show energy prices across the Midwest throughout each day. This is a series of price maps from Wednesday, July 21st, 2011, which shows the changing actual price of wholesale electricity across the hours of the day. The time of day is registered in the upper right corner. The price maps are a direct reflection of the least cost deployment of resources throughout the region, while respecting the reliability criterion to protect the system from any single generator or transmission outage. The prices depicted are actual clearing prices, or locational marginal prices, or LMPs for short. The prices are represented by colors, with the highest prices being orange to red in the 10 to 20 cents per kilowatt hour range, and the lowest prices being green to blue in the 3 cents to 0 cents per kilowatt hour range. While the video shows megawatt hour prices, we'll divide these by 1,000 and use kilowatt hour prices throughout the presentation to better make the connection to retail reality. These are the actual prices for wholesale electricity, and the prices which an economist would like to see motivate how people make their energy decisions. As you watch, think about these wholesale prices versus the average, time-constraint retail price that people and businesses actually pay, and the disparity between the two. Remember that the disparity is quite expensive in terms of contributing to a greatly underutilized but very expensive asset, the bulk electric system. Also, think about the load side assets, the end customer assets, that might want to be paid these prices instead of consuming energy for short intervals, a choice they would gladly make under many circumstances. And finally, if you see savings in retail price changes to enable grid efficiency, and/or allowing end customers to access the wholesale markets in some fashion, think about how these savings could be used by consumers and businesses alike to invest in our economy. This can happen and strengthen the bulk electric system at the same time. The dotted lines shown throughout the region are existing 345 kV transmission lines. The heavy dark lines shown on the map are the 16 elements of a $5.8 billion multi-value project, or MVP, portfolio of proposed transmission lines. This portfolio is specifically designed to reduce congestion in the footprint and enable least cost generation to reach load throughout the footprint. In December, the MISO board approved implementation of this portfolio after careful and considerable review of a very conservative business case that includes a benefit to cost ratio of more than 2 to 1. A 2 to 1 benefit to cost ratio is an extraordinary value in any business. However, for now, many low-cost wind generation resources are largely trapped in the West. This trend will play out through this peak day and virtually all future days until more transmission is built. What follows is an illustration based on events and conditions which occurred on Wednesday, July 21st, 2011. 12:01 a.m. Eastern Standard Time. It's just after midnight, moving into July 21st, 2011. The previous day was sweltering hot, and today is expected to be just as hot. Yesterday's peak for the MISO region was almost 104 gigawatts, about 15% of the electricity used in the entire United States. Today's forecast is similar. Instructions have already been sent to each of the over 1,300 generation and participating load-side resources in the footprint, letting them know what is expected for each hour of the day. These instructions will be monitored throughout the day and modified as conditions dictate. But every 5 minutes, a new instruction packet or reminder is set out so that everyone is up to date on next steps. Wholesale price volatility is a very real and daily phenomenon caused by widely ranging fuel prices, very limited storage ability, weather conditions, transmission line constraints, and other factors. You are looking at the state-of-the-art in terms of price setting, delivering prices that result in lowest cost system deployment and high reliability. The system planning and resource adequacy efforts have targeted only one end-user outage every 4,000 days. But that's not all. These prices are transparent to everyone and therefore used to inform future bilateral contracts, governing the value of these contracts by shedding a bright light on true costs. Where organized markets do not exist, price discovery is more of an art form. Throughout the ensuing description, we will weave in a few vignettes which mix fact and fiction to make some point of possible interest. However, despite any fictional elements, they are all entirely possible and realistic today. 1 a.m. We are 1 hour into implementing the grid management plan for the day. Prices are below 3 cents per kilowatt hour across the region, except on the southern Illinois to Indiana border, where a transmission constraint has limited the flow of low-cost power into the area, and 10 cent per kilowatt hour generators have been brought online to serve the load. Just 130 miles north of the 10-cent energy price, 0 variable cost wind resources are trapped and cannot get out due to lack of transmission line capacity, driving prices to 0. Operators in the MISO control room are constantly looking at the weather forecast and system conditions. Software runs quietly in the background collecting data from 250,000 points every 4 seconds across the grid on cyber-secure channels. The same systems check every potential grid failure point every 89 seconds and calculate protective reactions for every one of them. Meanwhile, prices are determined and posted every 5 minutes for energy and multiple ancillary service products for each of 1,976 locations. You are looking at just energy prices, and not all the separately priced ancillary services products, although there is a very high price correlation between all these products at any moment in time. 2 a.m. With more people in bed and cooler temperatures, load across the region has dropped off further. Wind generation output is at 3.5 gigawatts, leaving 6.5 gigawatts of nameplate zero incremental cost wind capacity unproductive for lack of wind. Since load is down, transmission constraints are virtually gone, and the system is greatly underutilized. 3 a.m. Prices are near zero in the western portion of the MISO footprint. Wind farms producing with a fuel cost of 0 are willing to be paid anything above negative 2.9 cents per kilowatt hour, since they receive a production tax credit of 3 cents per kilowatt hour from the government. 4 a.m. MISO control room operators continue to monitor the software outputs and keep an eye on the 10 by 70 foot data screen that dominates the control room in Carmel, Indiana. Systems in MISO's St. Paul, Minnesota backup control center, 581 miles away, are updated on a real-time basis, and operators are ready to take over on a flash cut basis in the event of a failure at the Carmel Control Center. Load on the system settles in at its minimum for the day, 67 gigawatts. The equivalent of more than 23 nuclear plants will be fired up in the next few hours to meet the peak later in the day. Wind prices in the west plummet to 0 or less as load drops off and the wind is generating at 3 gigawatts. 5 a.m. People in Michigan are starting to get up and turn things on, and prices are rising as more expensive, although still cheap, generation is brought online in anticipation of the daily ramp-up. Winds in Lafayette, Indiana are non-existent, and the football field-long blades stand idle in what is usually a very windy area. 6 a.m. Demand is increasing faster in the eastern portion of the footprint than in the western portion, as the sun continues to clear the eastern horizon. A price map of each ancillary service product would show very similar price separation and variability across the region. It's still early morning, but a price disparity between Iowa and Michigan is already obvious. Incremental energy in Iowa is nearly free, while in Michigan energy is already up to 7.5 cents per kilowatt hour, reflecting transmission constraints that prohibit less expensive energy from flowing into the state. Michigan will clearly benefit from additional transmission capacity flowing towards the state. 7 a.m. Winds have started to pick up in Lafayette, Indiana, and wind generation is ramping up inside a traditionally transmission-constrained area. Low-cost generation is trapped in the area because there is not enough transmission to move it out to where it's needed. This results in all generators in the area that are subject to market prices receiving a near-zero price. The two dark lines out of the area show proposed transmission lines that will ultimately move the low-cost energy and result in a lower cost to the overall footprint. Wind creates some unique challenges to a balancing authority. Despite its near-zero variable costs, in a small balancing area, wind's variability can cause both reliability issues and additional costs, as other resources are needed to manage the variability and provide backup capacity. MISO transitioned in 2009 from 23 balancing authorities to a single balancing authority, allowing for these challenges to be better managed at the lowest cost. In addition, the geographic diversity of MISO's footprint moderates the overall variability of the wind. The scale of the footprint also provides more options in the siting of wind, allowing for access to higher wind capacity resources for states in wind-challenged areas. MISO is similar in size and geographic diversity, and previously similar in terms of proliferation of balancing authorities to the Western Interconnect, minus California. 8 a.m. Trapped wind in west central Indiana is pushing prices to zero and less, while nearly adjacent areas are at 10 cents per kilowatt hour, more than 2 times the average system price. MISO's market software has properly determined that raising the price on the high price side of the transmission constraint and electrically pushing back on the constraint will enable the lowest total cost for the region at this moment. Energy traders caught short and in the red area are not happy. Dealing with constraints is also an area where end customer resources could prove to be of value in the calculations aimed at low cost and maintaining reliability. Software overlays from either aggregating energy companies or independent aggregators could configure end customer resources to provide energy and ancillary service equivalent functionality to the grid operator, who remains legally agnostic between the possibilities. Over the long term, traditional generation assets and end customer resources that can be configured to provide grid services could each contribute according to their marginal cost structures and fine-grained functionality. In 2009, MISO also launched an ancillary services market. This resulted in a large increase in the value being provided by MISO as measured annually in its ongoing value proposition study. A good example of this is the provision of frequency regulating reserves, which manage the second-to-second changes in load that continuously occur on the system. Prior to 2009, each balancing authority in MISO managed their own regulation, typically with reserves held on its newest coal units, which tended to have the best control systems. In total, over 1,100 megawatts of low-cost coal generation was held back for regulation. The consolidation into a single balancing authority and the provision of regulation through a central market allowed the regulation requirement to be reduced to less than 400 megawatts and also allowed the requirement to be met with less efficient units, freeing up the most efficient units for energy production, the equivalent of 4 low-cost coal units. The result is an annual savings of $176 to $195 million. 9 a.m. Interpreted appropriately, locational marginal prices are like little markers pointing towards opportunities to lower cost and improve reliability. Constraints, which are indicated by price differences in the region, should be examined for ways to improve the cost efficiency of the system. Detailed examination should consider several options for solving each constraint, looking for the most cost-efficient solution. Options might include additional generation, additional transmission, and load-side resource participation opportunities. In high-load areas that experience constraints which block delivery of low-cost generation, enabling demand response options can be a very efficient option. Currently in the MISO region, most demand-side resources are not offered for use by the wholesale market, except in emergency situations, creating economic inefficiencies. Load-side solutions are also inherently clean, fast, and do not suffer from NIMBY and banana issues. Several companies have now adopted the green button approach, a necessary step in the direction of end-user bill control. Of course, this isn't a one-size-fits-all solution. In some cases, the cost of a constraint may be small enough, or the constraint may occur so infrequently that the best economic decision is to accept the constraint and the inefficiency that goes with it, because that's a lower cost option than any of the other options. In most of the western portion of the Eastern Interconnect and the eastern portion of the Western Interconnect, customers only have the option of wholesale market access through their local energy company based on retail tariffs. Other areas of the country allow aggregators to approach customers with a wide variety of increasingly innovative offers related to participation in wholesale markets. State regulators have to sort out the right approach for customers. Back in the MISO control room at 9:34 a.m., operators declare a maximum generation warning as load is tracking ahead of forecast and forced outages are exceeding modeling expectations. Models suggested the warning 4 minutes ago as the appropriate next step. At 9:35, the frequency dips to its low for the day, at 59.964. Generation is falling a bit behind the morning ramp-up. 10 a.m. Things continue to heat up, and the morning ramp, or the rate of load increase, is formidable. To further complicate the ramp, wind is falling off sharply, and wind turbines are slowing across the region. Current forecasts are for peak wind generation to be a full 3 gigawatts less than the peak wind from yesterday. That's about 3 nuclear plants worth of generation missing in action. In addition, 2 other challenges are surfacing. The weather pattern across the entire MISO footprint is unusually homogeneous today, taking away the inherent ability of the system to take advantage of weather diversity in a large footprint. This will cause more resources to be committed later this afternoon. In addition, PJM is facing its peak day for the year. As a result, imports from PJM's western plants, which often provide some energy to take advantage of higher prices in the eastern part of the MISO footprint, are drying up as prices rise substantially in the mid-Atlantic states. MISO's grid management software has been subtly altered over the past couple of years from just bringing on enough generation to meet changes in load to align with a new approach to grid management. The new objective function of the software is to run the grid as efficiently as possible while maintaining reliability using any resources available. This is an evolutionary change with revolutionary implications. An efficient grid is a low-cost grid and a reliable grid. To run an efficient grid, the operators need to deliver energy along with a suite of ancillary services like frequency regulation, spinning reserves, non-spinning reserves, and so on. These are well-defined capabilities to the grid operator, who is legally agnostic as to who provides these services. The service providers are now called resources, and these services can be provided by traditional generators or equivalent actions on the customer side of the equation. Both traditional generators and customer-side assets are offering their capabilities into the market, and the software is selecting whatever the most efficient resources are. Resources that provide the lowest cost energy solution to meet demand in a reliable fashion. Every day, more customer-side load assets are being offered into the market and replacing traditional generation assets that are higher cost. We are still very early in the trend towards customer participation, but the trend is there, pushed by technology advances and increased customer awareness through smart grid projects and similar efforts. At this moment, thousands of entrepreneurs are dreaming up ways to enable customers to participate in the process and leverage this new system. The beneficiaries are the end customers, and just in time, given price pressure driven by retirements of aging generation plants and higher plant replacement costs, not to mention sorely needed distribution upgrades. 11 a.m. Very high prices, in excess of 10 cents per kilowatt hour, start to surface in central Illinois as the Chicago area draws energy from the southwest and transmission lines near capacity. While generators in the PJM region had been selling into the MISO market earlier in the day, MISO is now exporting over 500 megawatts to PJM, a trend that will continue to grow through the hottest part of the day. The occurrence of very high and very low prices in close proximity is reflective of efforts to achieve low cost across the footprint in the face of constraints. Think of the transmission grid as a network of pipes with free-flowing water running through them. A constraint is like a section of pipe that hampers the flow of cheap water. One way to increase the flow of cheap water through the network would be to blow into the pipe towards the cheap water and spread it out into other pipes. Grid operators do that by turning on more expensive generation at the other end of the constrained line to push back against the constraint, resulting in increased prices on one end of the constraint. This causes less stress on the constrained line and the lowest cost possible in the footprint, given all the electrical constraints and resources available. Of course, it's mathematically far more complicated than this simple example. 12 noon. Prices have reached above 10 cents per kilowatt hour in the east, more than a 400% increase over the early morning hours. And electrically equivalent gas prices have gone up 400% in 8 hours if you own an electric vehicle. The wholesale markets are a true reflection of the actual cost of electricity at each of the 1,975 pricing locations, which are updated every 5 minutes. The reality is that at this moment, the real cost of energy in Illinois, Indiana, Michigan, and Ohio is well in excess of the retail price every customer is actually paying. The disparity between the real wholesale price and the retail price that actually drives customer decision-making leads to massive inefficiencies, waste, and severe underutilization of a trillion-dollar asset. Retail time-of-use pricing that at least roughly aligns with the wholesale reality could help a lot, but that's tricky business as well. At 12:45 p.m., a plant in Indiana trips offline, and the loss of over 400 megawatts of power ripples across the interconnect at 60% of the speed of light, and frequency in the entire interconnect dips to 59.967 Hz, the second lowest for the day. The dip is expressing the loss of generation. Through a combination of software-driven actions, frequency recovers in less than 5 minutes. Synchrophasers across the eastern half of the continent log the event to within 1/1,000,000th of a second, the time it takes electricity to travel 2 football fields. In the world of grid happenings, it's a very minor occurrence. The grid is always protected against any single event, and the only impact of the instantaneous loss of over 400 megawatts is a slight price increase as more expensive generation comes online. At the same time, the grid is immediately reconfigured to protect against the next potential event. 1 p.m. The temperature is nearing 100 degrees, and wind generation has dropped off to less than 1 gigawatt. Effectively, only 1,800 of the 30,000 wind blades in the region are producing at full capacity. Grid operators dispatch the next batch of least cost generation, which is almost always the most expensive generation on the system. Average prices in the east are 300% higher than prices in the west. Some rain and cloud cover flattens the load growth at the 100.5 gigawatt level. The system peaks at 3.5 gigawatts less than yesterday. In Indiana, the Alcoa smelter in Newburgh on the southern Indiana border has been providing frequency regulation service to the grid since early morning, reacting to a 4-second signal, just like every other day. Now they dropped their demand by 80 megawatts from 480 megawatts to take advantage of a $200 per megawatt hour price. The economics just switched over from making beer cans to making negawatts, and as much of the smelter capacity as possible is reduced for an hour. For a typical aluminum smelter, electric power accounts for 30 to 40% of the factory cost of producing primary aluminum. In the continental United States, Alcoa Incorporated currently owns and/or operates 10 aluminum smelters and many associated fabricating facilities with a combined average load of over 2,600 megawatts. 2 p.m. The end-use customer events in the last hour highlight the beginning of a trend towards more end-use customer participation. Huge decreases in communications costs and advances in digital technologies are enabling new load side or customer side of the meter assets to have the flexibility to empower customers to control their bills. Demand response resources have been called upon east of MISO, lowering prices for the interconnect, but MISO's demand response resources are not needed since reserve margins are adequate on this day. Looking at the colors and changing patterns, it is impossible to infer anything about state boundaries, highlighting that states are all essentially in the same electrical boat when it comes to the bulk electric system. It's also tempting to look at the map and consider incremental transmission builds and who wins and who loses. States with lower cost resources have the benefit of economic stimulation through increased imports to other states. States gaining access to lower-cost resources have the economic stimulation of lower-end customer bills, freeing up cash for local investment. MISO's detailed and public analysis shows that every subregion is a winner for the proposed transmission builds. 3 p.m. High prices in the eastern and central portions of the footprint ease due to a combination of flattening demand and an increase in the amount of power imported from external suppliers that occurred during the prior hour. A weather front moving across the Midwest is lowering humidity levels and causing increased cloud cover in some areas, ending the escalating temperatures. This relieves most of the congestion on the transmission system for now. However, at 3:55 p.m., another plant in southern Indiana with a capacity of almost 500 megawatts trips offline. The grid software, which runs a co-optimized real-time energy and operating reserve market, has procured and deployed enough reserve capacity to protect the system. Reserves represent another ancillary services product for which end customer resources can be readily configured via software and offered into the market for payment. Again, the event is easily handled by the software, which reconfigures the grid and gives everyone new marching orders within just a few minutes. 4 p.m. Load for the MISO region peaks at 100.5 gigawatts, down about 3 gigawatts from yesterday's peak due to the slight change in weather for parts of the region. Current real-time prices in the Milwaukee area are some of the lowest across the footprint, as temperatures peaked there hours earlier as a result of the changing weather conditions and transmission constraints on the Wisconsin-Illinois border. Automatic 5-minute dispatch instructions and price signals are incenting generators in the Milwaukee area to reduce their output to mitigate the congestion, trapping low-cost power that could otherwise reduce costs across the footprint. The short black line connecting Wisconsin and Illinois represents a proposed 6-mile segment of 345 kV transmission that would alleviate this congestion, allowing customers to the south and east access to this low-cost generation in Wisconsin. Just to the east, PJM sets a new all-time peak of 160 gigawatts, at the same moment that wind in PJM reaches its lowest point for the day at 300 megawatts, down 1.3 gigawatts from earlier in the day. The west to east price pattern is indicative of the normal relative price arrangement, teeing up the need for west to east transmission to deliver lower cost resources where prices are higher. 5 p.m. After several very hot days, customers are demanding more energy for air conditioning. Traditional generation assets are stressed and many have had to derate and reduce output due to temperature. MISO operators are immediately and automatically notified of lessened capability via software. Wholesale prices are between 10 cents and 20 cents per kilowatt hour across the region. Peak hours drive the need for new construction in generation, transmission, and distribution. At this moment, the 61 million people in this picture are all making electricity decisions based on average and at this moment far too low retail electricity prices. Retail prices across the footprint signal end users that electricity is no more valuable now than it was at 4 a.m., despite a more than 20 cent a kilowatt hour cost difference. Implications of low retail prices artificially incenting demand include unneeded construction, higher bills, unnecessary pollution, and increased energy dependence. In southern Indiana, Alcoa returned to full beer can production 3 hours ago. But now prices are at 45 cents a kilowatt hour, and they happily shed 80 megawatts again for the next hour before returning to a standard production schedule. Organized markets and the ability to profit from responding to power prices help make the economics of this facility work. The United States, once the leading aluminum producer, has been surpassed by China, Russia, and Canada. The long-term viability of these types of facilities within the U.S. is contingent upon finding methods to reduce costs. 6 p.m. Things are now starting to cool off in the West, and prices are less than half what they were just an hour ago. 7 p.m. Even as temperatures cool slightly, MISO operators are still faced with 9 binding constraints in the region, 3 more than last hour. Each of these constraints means that low-cost power can't reach load. On a day like today, operators are never relieved of this effort. During the cooler morning hours, they only had 3 to 5 constraints to manage, but during the day, as many as 13 were actively being managed. 8 p.m. The heat index along the Lake Michigan shoreline in eastern Wisconsin has fallen significantly in the last hour. Demand there continues to fall, and prices continue to signal for less generation. Additional constraints, effectively a lack of transmission capacity to transport cheap energy out of this region, trap low-cost generation in the area. 9 p.m. As streetlights come on and households increase power consumption, the consistent decline in demand over the last couple of hours is momentarily slowed. The continued removal of generating capacity from the system combines with this brief period of flattening demand to cause the need for some short-term, high-cost generation relief. Constraints continue to trap generation in Wisconsin. Although prices are higher for this short period, it is still the least cost deployment for the region considering what had to be done in previous hours and the needs ahead. Economics for Alcoa have again flipped from making beer cans, and 80 megawatts is again shed in exchange for the 34 cents per kilowatt-hour price. Alcoa is a great example of where a large end customer can actually change their operation to improve profitability and contribute to an efficient grid at the same time. At the other extreme, a residential electric hot water heater is pretty much the same as a smelter and can provide the same services to the grid. Aggregated across many residential customers, such an asset can function as a low-cost, highly reliable asset for use in frequency regulation, reserves, or energy markets. Many cooperatives and municipals are at the leading edge of using residential hot water management programs to cut peaks and reduce their system cost. Even if we undertake massive reforms to better manage electricity, since there will always be locational price separation and intermittent price volatility, there will always be opportunities for end customers to participate in a meaningful way. 10 p.m. Load resumes its decrease across the footprint as people go to bed and temperatures drop. Prices also begin to decrease as the system has more generation than needed to meet demand. The only places prices have not dropped is in southwest Indiana, where the two large coal units had tripped offline earlier in the day as previously reported. The transmission capacity in the area is not enough to support low-cost imports into the area, resulting in the need for high-priced generation to meet the local load. 11 p.m. Demand begins to decrease more rapidly as temperatures drop and more people go to bed. Congestion continues in southwest Indiana. 12 a.m. The system becomes unconstrained as load continues to drop. MISO operators begin the cycle again, driven, as always, to provide a low-cost, reliable grid to the region, shedding light on the real cost of electricity and assisting the region in planning for future improvements.